and it's live. People will start jumping on. I'm going to grab the link and start tweeting it, etc. Perfect. Hey, everybody. Perfect. Hey, everybody. Perfect. Trying to figure out why. Let's see. We'll do some testing just to make sure.
Okay. And therefore I can clear my throat. I'm going to mute myself a minute.
Okay.
Ready when you are.
All right, tweeting it. Tweeted. Hey, everybody. Hey, Hendrik, how are you? We got a guy watching from over in Europe.
And since I was just in Europe, I wonder where he lives.
You're in the Netherlands, right, Hendrik? Hey, Mirko. Mirko is watching from St. Bartholomew. He went through the eye and eye wall of Irma, St. Bart's. We're going to get started in just a few minutes. I'm going to let everybody join in.
And of course, I'm here in Miami, Florida.
All right, you guys, how can you you hear me okay? And Stanley, you'll say hello real quick. We'll just do a quick sound check.
This is Stan Goldenberg, signing on from Miami, Florida.
Audio good, folks? Right now we have 45 people tuned in.
Welcome.
Just got to paste it when it says it's good. All right, I've got to put it on Facebook and then we're ready. I need a social media manager. Hispaniola's tuning in.
Been there.
I bet you have. All right. All right, I posted it on all my major social media platforms, so we'll get started here in just a moment. Everybody, thanks for tuning in. I'm going to start here with our hard start, as they say, in just a moment. I'm going to be able to trim all this part off and post this later tomorrow, and all the front part will be trimmed off, so it'll be nice and neat, and you guys can share it, etc. So it'll be on YouTube tomorrow, and you'll be able to share it with anybody you like. So we'll start here in just a moment.
Mark, my picture might pause for just a minute, but just give me a moment.
Sure. And you guys feel free to share this link with anybody that you like. It's public. It's not monetized. There should not be any ads or commercials, hopefully. And if there are, I'll make sure that there are not when I put this on the on my channel. I can't remember if I turned monetization off for the live stream. If I forgot, sorry, but it's not intended to be monetized. This is a public education event supported by our patrons on Patreon, which I'll talk about in just a moment.
Just to let you know, I just looked at it on your YouTube site. I can see it loud and clear.
Oh, good. Thanks, Stan. All right, what do we got here? It's about 4:10, so we're going to get started here in about 10 seconds. All right. Yeah, lost a lot of weight. Thanks for noticing. All right. All right, and 3, 2, 1. Hey, good afternoon, everybody. Mark Sudduth, HurricaneTrack.com, and welcome to the inaugural episode, the premiere episode of Hurricane U, Hurricane University, as I call it, the hopefully fun and very interesting way to learn more about tropical cyclones. That's the general term, but we all know that word hurricane raises a lot of eyebrows. This originally was going to be an audio podcast that was going to be produced as I traveled around the country starting this week, interviewing different experts in the various aspects of tropical storms and hurricanes. And then I'd produce these podcast episodes very similar to what you hear if you tune in to The Daily from Michael Barbaro from the New York Times, a very well-produced podcast. But because of a virus that we all are very familiar with, I'm in my daughter's bedroom in Wilmington, North Carolina. That's her 65-inch television, and she's out doing her deliveries for Domino's Pizza while I produce the first episode in her bedroom. So what a world, but things have changed, but we got to keep focusing on what's coming, and hurricane season's coming up. But this is going to be a no fear zone. We're not here to try to scare people. We're not here to do anything like that. The more you know about something, the less fearful you should be about that subject, no matter what it is. And so that's what this is all about. Hurricane U is going to cover what hurricanes are, why we have them, seasons, ingredients, preparedness, tracking, models, insurance experts, and other topics to help us, almost like a master class. But instead of me doing it all the time and me talking to you, I'm going to have expert guests to come in and help expand upon my knowledge base and hopefully yours as well. And with that being said, I would like to bring on my first guest. Hopefully this will come up onto the screen. Let's see. We got it there, but I got to get it onto. And since this is live, all sorts of interesting things can happen. Da-da-da, Stanley Goldenberg. There he is. So, this guy right here, I have known since 2002 in person, but I knew about him before that, way back in 1995, from a show that I saw on NBC called Cyclone. And I'm going to let him take it from here. This is Stanley Goldenberg. He is in Miami, Florida. We are live. We appreciate you tuning in. Stanley, who are you and why are you here?
Well, listen, so glad to be with you, Mark, and so grateful for all the work you've done through the years that supplements what we do at the Hurricane Research Division. I work with, it's the Atlantic Oceanographic Meteorological Laboratory, quite a mouthful, Virginia Key, Florida. That's basically near Key Biscayne. And I'm in one of the divisions there, which is the Hurricane Research Division, and we're part of NOAA, the National Oceanic and Atmospheric Administration.
Yep.
Right there. Now that we got that all out of the way.
Quiz later. Remember, this is Hurricane U, so we're going to quiz y'all later. What does AOML stand for?
HRD, NOAA. And in between NOAA and AOML is OAR, which is the Office of Oceanic and Atmospheric Research.
How about
And
that?
they're very important because there's two main branches in NOAA. There's the operational branch, which is the Weather Service, the National Weather Service, things like the National Hurricane Center, National Weather Service Forecast Office, Severe Storms Forecast Office. You have all those things that are branched under the operational arm. Then you have the research arm, and the research arm is OAR,
Right.
Office of Oceanic and Atmospheric Research. And there you have places like where I work, AOML, you have Pacific Marine Environmental Laboratory, you have the Severe Storms Laboratory, you have all these different kind of these geophysical fluid dynamics laboratory.
Right.
So there were one doing the research. In fact, we have a joke we tell at HRD, it's not really a joke, is the National Hurricane Center, which is under the Weather Service, they make the forecast.
Right.
We work on making the forecast better
Ah,
by doing the different research
it's a good
that
slogan.
we then funnel to the Weather Service,
Sure.
National Hurricane Center. In fact, to hurricane and tropical cyclone forecasters worldwide use much of what we have, and of course we look at much of what they have. And you mentioned tropical cyclone was the generic name. People have to realize that these tropical storms, tropical cyclones, are called hurricanes in the Atlantic, the North Atlantic Basin, East Pacific, and Central Pacific.
Mm-hmm.
And then in the West Pacific and various other places, they're called typhoons. And then certain places, they're called cyclones.
Right.
And so there's different names, but they're all the exact same thing. They're a tropical cyclone.
Right.
The cyclone is basically a low pressure that you're going to rotate the winds cyclonically around. And these happen to be in the tropics. You have mid-latitude cyclones, which are what brings all the cold fronts and the warm fronts and things like that. But these are tropical cyclones, they're a different animal. But let you, oh wait, can I say a few things about hurricanes or tropical cyclones in general first before we get started?
Yeah, and that's the whole point of this, is we want to start and kind of have a baseline here to, again, expand all of our knowledge. You know, we see stuff in the media, we see television shows, we see movies, and we might have this preconceived notion of what hurricanes are all about, and maybe this will help to sort of dispel some of that and maybe hopefully tighten up your knowledge base. So certainly, go right ahead.
Well, I call this why hurricanes, or all the other names they're called, are the greatest storms on Earth.
Mm-hmm.
And we need music in the background for this, Mark, drum roll, please. The whole hurricane can cover as much as 500,000 square miles, and with as much as 50 to 100,000 square miles with hurricane force winds, because sometimes way out there they're less.
Right.
Andrew was 2,500 square miles of F3, the equivalent of F3 tornado winds. That's how much that area covered, like hundreds of tornadoes.
Sure.
Some hurricanes are as large as 10,000 square miles of strong winds. You can have up to a 30-foot storm surge, that's the wall of water that comes in along the coast, covering dozens of miles of coastline, and lesser amounts covering 100 miles or more, demolishing most of the things in its path. Buildings further down. In some cases, storm surge has been responsible for many thousands of deaths, as in the 1900 Galveston storm. Some people heard of that, where they estimate about 1,200 people died, primarily.
12,000. Sorry, 12,000.
That storm surge not only demolished the buildings, then the debris from the buildings would become battering rams to kill people and demolish more buildings. The Barbados storm, which was way back, hundreds of years ago, and the Bangladesh cyclones. Now, those are hurricanes in the Indian Ocean area. Bangladesh cyclones, which have killed 500,000 people, sometimes at a time.
Right.
At times, the coastline is literally transformed. I mean, you have new inlets created. You have all sorts of changes when you have a severe storm. Roads and even major highways, bridges are sometimes demolished. And as we saw in 2005, the right combinations of winds of storm surge can breach levees, like with Hurricane Katrina, flooding an entire city.
Sure.
Then you have the rains. The torrential rains can sometimes cause extreme flooding and many deaths inland, far inland, away from the coast, especially in mountainous regions.
Right.
Hurricane Mitch, when it hit Honduras, Nicaragua in 1998, it was only a Category 1 storm at that point, stalled in that area, caused incredible flooding, killed 10,000 people. That's as recently as 1998. And then there was the incredible flooding in your area, in the Carolinas, by Floyd in 99, And some have asked, isn't a tornado an even greater storm? It's true that about 3% of the tornadoes can reach winds faster than the strongest hurricane.
Right.
But even the largest tornadoes are about how wide, Mark?
Yeah, a mile wide or so, 2 at the most.
Just a mile wide. I mean, and less than 1% the size of a hurricane. Like I said,
right.
The whole eye wall of Andrew had the equivalent of about F3 tornadic winds, and that covered 2,500 square miles. And the fact is that many hurricanes spawn numerous tornadoes. There's almost like a daddy of tornadoes.
Sure.
So when the hurricane hits land, all of a sudden you have sometimes these little tornadoes, but tornadoes don't contain hurricanes. Hurricanes contain tornadoes. Hurricanes also can last for several weeks, at least days, and tornadoes are a matter of hours or even minutes.
Sure.
And when Andrew hit, by the way, people from the tornado belt who came down here to help us described it like it was hundreds of tornadoes had hit. That's the only way they can describe it. Go back home. The devastating winds of a tornado might affect a building for a matter of moments, possibly minutes, whereas the devastating winds of a hurricane can affect a city or region for hours or even days.
Yeah.
Just like with Dorian, this last year just sat on top of the Bahamas. So what are the winds capable of doing? Incredible damage. And then finding out that the winds are stronger. We know the winds are stronger with height, but they can be one category or more higher, say at the height of about a 30-story building.
Sure, yeah.
You've got those kind of things. Now, to give you an idea of the energy involved in a tornado, picture the latent heat. We're going to talk about latent heat later. You're going to come back to that, Mark, because that's basically the driver, the energy source for a hurricane. The latent heat released in a hurricane, in a day can be the equivalent of about 420 megaton atomic bombs. The amount of latent heat released in a hurricane could power the electrical needs of the entire United States for 6 months. That's how much energy we're talking about. Also, the blackouts that come from hurricanes. If you've been through a hurricane, you know about the blackouts. The loss of power can disrupt the city or region for days or even weeks, and then the evacuations disrupt a whole area. I mean, Hurricane Floyd, almost the whole East Coast evacuated at some point, and also with Irma a few years ago. And it's just demolished many homes. There's so much, and that's why we call hurricanes the greatest storms on Earth. Let's take it from there, Mark.
And so with all of that, and that is a lot to take in, but that is the world of hurricanes, let's start at the very beginning here. Why does nature produce hurricanes in the first place? What is their role in the atmosphere and in our environment?
In a simple nutshell, the reason nature produces cyclones, whether tropical cyclones or mid-latitude cyclones, is you have cold air at the poles and you have warm air near the equator. So it's warmer down south, colder to the north or to the south, depending on what hemisphere you're in, and the Earth is rotating. So you have all sorts of things going on with the winds, and at some point it's trying to equalize that.
Right.
So as Dr. Neil Frank used to describe it, hurricanes are like nature's egg beaters, just trying to mix up the whole thing and trying to just equalize stuff. So it's just one of the many things that go on in the very, very complex atmospheric system.
So I've heard him say on a documentary that he was in, Dr. Frank, that if we didn't have hurricanes, we might have something worse.
I can believe it. I can believe it. So it's just nature's way of putting these things together. And by the way, I kind of laugh. There's people that think that every time we have a devastating hurricane, they like to blame it on man-made climate change. And I say, do you realize if we didn't emit any more CO2 from man for the next 100 years, we would still have devastating hurricanes?
Right.
It's just part of the whole atmospheric system. And we've had them as long as we can trace back, and we'll continue to have unless there's some enormous super ice age glacier climate shift that has, I'm sure, nothing to do with anything we can do. But I'm sure you would ask, how do hurricanes form? Is that right?
Yeah. So we talked about latent heat a little bit. What are the basic ingredients that need to be in place to give birth to a hurricane in the first place?
Well, let me start at the beginning. The hurricane needs several factors to form, or we'll just say even a tropical storm or a tropical cyclone. By
Right.
the way, the definition of tropical cyclone is very important. Tropical cyclone is when you have this tropical circulation, low pressure system, that you actually have the winds circulating cyclonically around the center. Now, in the northern hemisphere, that is, I better get it right.
Counterclockwise,
It's
right.
counterclockwise. And in the southern hemisphere, that's clockwise.
Right.
So those winds have to circulate. So you can have a low pressure system that's called an easterly wave. An easterly wave, you don't have those winds coming from the west in the bottom. So you might have
Right.
easterly winds at the top. By the way, we define easterly as from the east and westerly as from the west. So you have those easterly winds at the top, but then at the bottom, you don't. And I might get into that later. It really takes some diagrams to explain that. And by the way, for a lot of these things, let me put a plug in right now. The Hurricane Research Division under AOML has a tropical cyclone FAQ page, frequently asked questions. Tons of stuff. We've worked on that for years.
Sure.
Thanks a lot to Neil Dorst and many people who work with him. And you can post that website.
Right. I'll put that in the
Just look
description
up-
of the video.
Right,
That's
you can
right.
just look up TC FAQ, and
Yeah.
they'll see one that has NOAA.
Right.
And they'll be able to find and have all sorts of issues. So, but what happens is you have to have warm water, because I'll explain with the latent heat how the warm water feeds it. And it's thought to be at least 26.5 degrees Celsius. Now,
Around
we've
80
seen them form-
80
Say
Fahrenheit.
again, sorry.
Around 80 Fahrenheit for those of you playing at home.
Right, and now we've seen them form over cooler,
Right.
and of course, we've seen them not form over warmer.
Yeah.
But that's basically around that temperature of water. And then you have to have some sort of low pressure system.
A kick.
Now go ahead.
Sorry, a kick. You got to have a pre-existing. They don't just
You gotta
form
have
out of
something pre-existing.
nothing. Right.
Now, where most of the Atlantic storms form from. Oh, by the way, like I said, the tropical cyclone, the lowest tropical cyclone we call a depression.
Right.
So we might say this thing is an easterly wave or it's a tropical disturbance, but as soon as you get that full circulation, no matter how weak it starts circulating, then they say, okay, this is a depression. Usually the winds are at least 20, 25
Phase
miles
one.
per hour.
Right.
I don't have the chart in front of me. But then if it gets a little stronger, it's a tropical storm. A little stronger, it's a hurricane. Hurricanes have, just to do a sidetrack here, Cap 1, 2, 3, 4, 5.
Right.
It's called the Saffir-Simpson scale. That's Herbert Saffir, who was an engineer, and Robert Simpson, who was a meteorologist, who used to be director of some of our organizations down here. And they put together just a scale for the different stages or strengths of hurricanes. And category 3, 4, 5, we call major hurricanes.
Sure.
I don't like calling 1 and 2 minor hurricanes,
Right.
because to me, no hurricane is minor. So, back to this, so we have the different stages, but to get that depression, you might have a wave. Another thing sometimes you have is the end of an old cold front,
Right.
because you have this, we call it vorticity. Vorticity is circulation,
Yeah,
measure of
spin.
circulation
Sure.
in the atmosphere. So you have this vorticity associated with it. You have some disturbance there. The key is you got to get that pressure down. When the pressure goes down, it draws the winds in. Because of something called the Coriolis parameter. Coriolis parameter is simply the fact that if winds are flowing, if the air is flowing towards a low pressure system, kind of like here's the bottom of the bowl,
Yep.
and the winds are coming down the bowl, because that bowl is turning,
It gets deflected.
or Earth is spinning, it doesn't take a straight path.
Right.
It starts to cycle. And at the bottom, because of friction, it spirals into the middle.
Right.
So you got to have that low pressure to draw the winds in. This is basically nuts. You throw all those kind of ingredients together. We usually have easterly waves. So these disturbances come off of Africa, low pressure system, a lot of clouds, a lot of rain with them, and then they come over the eastern Atlantic Ocean. So what happens when it comes over the warm water and you have these winds blowing over the surface of the ocean, it moistens the air. So it gets saturated, just fills up with water. It evaporates that water into the air. Now, what latent heat of condensation is is it takes a lot of energy to take 100 degrees Celsius or 212 degrees Fahrenheit water and change it to vapor.
Right.
So that transition takes the latent heat of evaporation or condensation. It's the same thing in reverse. It takes a huge amount of energy. So that's happening to create all this water vapor in the atmosphere and have this saturated air. Well, as that spirals into this low pressure system or comes in, it has to go up. So at some point you have what we call convergence.
Right.
That's when
the
the
air
wind,
coming together.
the air comes
Right.
together. When it comes together, it has to go
Right.
somewhere, so it goes up. When you lift that warm, moist air, it starts to cool as you raise it in the atmosphere. As it cools, that water condenses.
And you get the rain, the
When
precip.
that vapor, I'm sorry, water
Right.
vapor condenses. When that water vapor condenses, it releases all that latent heat. That's
Yeah.
what we talked about, like it could power the electrical needs of
Right.
the United States for 6 months. Huge amounts of energy. Well, if you warm the center, what happens is, if you understand, if you warm a parcel of air, it spreads the molecules out. Therefore, there's not as much air in the column,
Ah,
and the pressure drops.
lowers. Yes.
Right. So I still got, you know all this stuff.
Thermodynamics.
I'm explaining it right.
Right.
And so the pressure drops. Well, if the pressure gets lower, guess what? That bowl gets
More.
deeper. It's drawing more air in.
Right.
So more moist air comes in, goes up, continues the process. You keep warming that column. Now, what inhibits that from getting stronger is what we call either intrusions, we call it dry air. Some
Sure.
people have heard of Sahel air, Sahel. And so if you have some real dry air come in, it might just stomp that stuff out. But the other thing is what's called vertical shear. And vertical shear is the difference in winds, the horizontal winds, from the bottom, from the lower levels to the higher levels.
Right.
So if there's not much difference in those winds in the atmosphere, then the hurricane can organize this like chimney in the middle, these exhausts where the winds are coming out. But if that vertical shear is really strong, it tilts that.
Sure. And it disrupts
Or
the process. Right.
It disrupts it or it rips it apart.
Yeah,
We've literally seen the shear get so strong over a storm, we call it decapitation.
Yeah.
It just whisk away all the other clouds, and you have this little swirl left on the surface.
A naked
that
swirl.
dies out
Yeah.
usually very quickly.
That's right.
And so once this process goes, if nothing's interrupting it, and you have warm enough water, then it just keeps intensifying. So an example like Hurricane Andrew. Hurricane Andrew came off as an easterly wave off of the African coast, started to develop, became a depression, became a tropical storm, so got a little stronger, organized looking system. But then as it started to move north, there was this disturbance in the upper atmosphere, we call it an upper level low.
Right.
And that low was kind of creating a lot of vertical shear over Andrew, and Andrew just started to fall apart. In fact, the headline of Miami Herald said, Andrew weakens and moves out to sea. Don't we wish? And but all of a sudden, that thing moved out of the way, and Andrew had free play over very warm water and almost no vertical shear, and it just exploded. And as sometimes happens, like with Hurricane Michael as well, it went from tropical storm to Category 5 hurricane. And with Andrew, less than 48 hours.
Right.
It was about the same for Michael. So that we call that rapid intensification. So that's basic how a hurricane forms. And how a hurricane falls apart, it either moves over cooler water, you cut off that source, or it moves over land, and you also cut off that source of all that energy. And it just depends on that exact situation, how strong it was, or super strong vertical shear comes along. These things tend to start to weaken the storm, and eventually it'll dissipate. Although when they come over land, they can pack a wallop for a long way. They might not be a hurricane, but they can be a tremendous rain producer far, far inland. So that's basically the anatomy of a hurricane. And unless you have any questions, you can move on to the next topic.
Right, so let's recap there. We need the warm water, about 80 degrees Fahrenheit, a pre-existing weather system in the atmosphere. They don't just pop up out of nowhere. Something has to seed them, you know, that kick. Light winds in the atmosphere, preferably at all the levels, so that that convection can go efficiently and get that heat engine running that's not disrupted.
Well, let me be clear with the light winds. A small difference in the winds between
with height.
the lower.
Right.
and the upper atmosphere.
Right, so that it can,
So it's the
that can,
difference.
right. Yeah, that you don't want to tilt those thunderstorms in the vertical. If the more vertical that hurricane can stack, the stronger it could become, all the other factors being equal. That the wind shear is important. So I have a question from one of our patrons, one of our supporters. This is from Michael down in Florida, and this is a great one here. What determines, have you guys figured out in your lab down there, what determines the physical size of a hurricane? Why was Andrew fairly small, but Floyd so much larger? Dorian was not very large compared to Ike. So what's the deal there? Why are some hurricanes very expensive and some are much more compact?
Well, first of all, let me say that's a very good question. And one thing people have to understand, the size of the storm has nothing to do with the intensity.
Right.
You have very small ones that can be Cat 5, and you have very large ones that can be Cat 5. I'll give another example. You had Hurricane Allen in 1980, the first storm I ever flew. And by the way, I'm wearing my flight suit. This is what I wear when I fly on the
yeah, he flies in them.
Planes like
Right.
the Gulfstream 4, the P3 Orion turboprop aircrafts. And this is my little patch that says that I've gone through the eye of hurricanes over 100 times. There's some people with a 400 patch. I don't know if they have a 500 patch. But Allen, the first one I flew, Allen was so large. On a satellite picture, it filled the entire Gulf of Mexico.
Yeah.
And it was a Cat 5 hurricane. Andrew, it's interesting to note, was very small when it hit southeast Florida. It crossed Florida as a major hurricane, stayed as a major hurricane, went into the Gulf, and expanded tremendously. And that sometimes happens with these. Something perturbs them, and they just change and change in size. And actually, can I tell you the truth? I don't know, and that's something we're still studying. There's all sorts of things that go into those different sizes, and some of the models, and that's where you'll talk to some of the modelers who can discuss this better. Some of the modelers are looking into this as far as can the model, the numerical model, match the size of the storm, bigger or larger.
Right.
And it's something there's still, because the models are getting better, but years ago, we didn't have models that could emulate those kind of features because they didn't have, tiny enough grid spacing to really feel out stuff like that. So that's something to ask some of them at a later point.
Well, would it be reasonable on a general scale here to assume that a large tropical wave, easterly wave with a large envelope of energy, could give birth to a large hurricane, whereas a smaller amplitude tropical wave would inherently give birth to a smaller hurricane to start? Later on down the road, different things I noticed a lot in the discussions, the forecast discussion, that when they move into the higher latitudes, they do tend to expand, but at their inception, at their birth, it just seems to be that the larger tropical waves give a larger birth, so to speak, than do the smaller tropical waves. Has that been your observation as well? Is that at least a starting point at the beginning of them?
I personally have not noticed that. I've seen large waves, when it finally starts to develop and get organized, wrap up tightly.
Yeah.
And I've seen, smaller waves. We don't look sometimes how big or large they are, because they go through a lot of evolution.
Sure.
Along the way. And but as far as going north, one of the reasons they really expand is when they transition.
Right.
So they can be a tropical cyclone, which is warm core. The center is warm. It can transition to a mid-latitude cyclone, which is very different. Those are the ones that have the fronts and things. So there's been a lot of study on that. It's amazing how much we know. It's amazing how much we're still learning.
Sure.
That's why we still do a lot of research with these things, and we learn more every year.
All right. So just to remind you all, you're about 96 people tuned in live. This is Hurricane U, like Hurricane University, and we're talking with Stan Goldenberg from NOAA's Hurricane Research Division and AOML, the Atlantic Oceanographic Meteorological Laboratory.
You got that good, Mark.
Just showing off. And He has flew through over 100 hurricanes himself as part of research and reconnaissance. And we'll talk at the end here. We'll get some personal stories from Stan. But as they do, that's our station identification, so to speak. And if you're tuning in live, that's what's happening. I'll go over a couple of other questions here.
Oh, by the way, let me just correct that one thing. I haven't flown through over 100 hurricanes. I've flown
Missions.
through the eye over 100 times.
Gotcha.
So sometimes on a single flight, we might go through the eye 5 or 6 times. And by the way, in addition to those, I've flown in numerous storms on the Gulfstream jet, which we don't fly through the center. So sadly, they don't count on my tally. And I've done that through many storms. And by the way, I've also helped process data for another plane, which is our Global Hawk. That's actually NASA's Global Hawk.
Right.
But NOAA was involved in a project using this. This thing flies, just to divert for a second, the P3s, we usually fly anywhere from 1,500 to 20,000 feet. The Gulfstream 4, about 45,000 feet. The Global Hawk, 65,000 feet.
Wow.
So we can actually get above the storm. It's unmanned.
Right.
And it's controlled by a huge operations center. And then there's those of us who process the drop sum data. Those are these little canisters, drop down, measure temperature, pressure, wind, and humidity. And so I'm one of the ones who has done that for a number of those flights. So go ahead, Mark.
All right, so we've gone over the ingredients, and so we also touched a little bit on the hazards, and I'll tackle that just for a moment, and then feel free to add to what I'm going to say. So the hazards of tropical cyclones, and again, this first episode of Hurricane U is more of a primer of where we're going to go from here. We will expand on these ideas, on these topics in future episodes. This will be once per week, hopefully. And we'll have different people come in and we will talk more specifically. But today, I thought who better than Stan Goldenberg, whose life has centered around hurricanes, at least from a career side, to help get us started with this sort of introduction. I call it Hurricanes 101. That's just the general term. So the hazards, okay, we know we have hurricanes. What do they bring? You know, Stan, as you know, we hear a lot about the wind. The wind gets the headlines. You know, Hurricane so-and-so is 150 miles per hour. And, you know, but there's more to it than that. And we hear about categories. People often erroneously base their decisions on the category that it is instead of knowing the whole package is all about. And that's what this series is going to be, is to try to expand your knowledge base so that you know the enemy here. Enemy sounds negative, but you know what you're up against. So, the hazards. We hear a lot about the wind. That's sort of the headliner. Storm surge, and we'll get into what the mechanics of all these are. If not today, then certainly in a later edition of Hurricane U. So wind, storm surge, the heavy rainfall, the torrential rain that can lead to freshwater flooding, and then sort of this double category, if you will, or hazard, downburst winds and tornadoes, kind of wrapped up together there. Did I hit it pretty good? Did I leave anything out?
No, that's absolutely right. And one thing people have to realize is the Hurricane Center, when they make their forecast, there's no way they can tell exactly which neighborhood some of these hazards are going to hit.
Exactly.
Tornadoes are hit and miss. They can pretty much tell you which side of the storm most of the storm surge will be on. They can give you an idea. And that storm surge, now you have personally been in the area and seen storm surge come up. I have not. I've seen it from the plane. We can see the coast inundated or an island inundated from our plane. But the storm surge, what people have to realize, people keep talking about, well, won't rising sea levels make hurricanes more dangerous? And they say, well, rising sea level, even at the worst predictions, which are way out there, are very, very gradual. You're not going to go out there one morning and say, oh, my honey, the sea level's a foot higher, you know, and the next day it's 2 feet. That doesn't happen. We're talking about very, very slow. The hurricane, the storm surge, however, so you're going to know what you're starting with. When the storm surge comes, I remember the video when people watch the National Geographic Cyclone video, and you've got the link to go to it on one of my YouTube pages, and it shows the whole hurricane portion. So it starts off, I think it was with Jim Leonard, in one of these storms, and seeing the storm surge firsthand.
In Guam, that's right.
Is shocked. Is shocked at how fast that water came up. And it can come up whether it's 4 or 5 feet or 15 or 25 or 30 feet. That thing comes up, and if you've ever been hit by water, you know that thing packs a humongous wallop with battering waves on top if you got the winds. And the storm surge is absolutely horrendous. But as far as the winds, understand that energy goes up with the, I always forget, energy of force. Energy, I think, goes up with the square of the winds, the cube of the winds, but
math.
A little extra winds means a lot more force.
Right. All right. So another basic question that I think people, I hear people throughout my career, most people know that there is a hurricane season. Oh, it's coming up to hurricane season. Not a lot of people know that it's actually half the year. But why do we have a hurricane season? Most of the tropical Atlantic, it's not like it all cools off. The Caribbean stays warm enough. So why don't we have hurricanes roaming around in the Caribbean all the time? And it's really August, September, October, the peak months. But why do we have a hurricane season specifically for the Atlantic Basin as an example here?
Well, let me wrap that up, because I'm glad you said specifically for the Atlantic Basin, because in the southern hemisphere, you have the peak in the opposite part of the year. And then in the West Pacific, they have a peak, but they just crank them out all year round. The Atlantic has had storms every month of the year. However, the tremendous vast majority, probably 98, 99% of them, have occurred from June 1st through November 30th.
6 months.
Then you can have them outside. Right, you can have them outside at that time. Then the vast majority of them, probably, I don't know the exact number, but I would say 80, 90%, especially of the major hurricanes, happen during the peak months, which is August, September, and October. And sometimes October can be one of the deadliest months. People seem to write October off and think it's all over. There's even a saying, October all over. No, no, no.
Yeah, don't we know?
Some of the deadliest, Hurricane Mitch, Hurricane Wilma, Hurricane Michael, just to name a few recent, those all happened during October. In fact, sometimes towards the end of October.
Sure.
So we've really got to get, but again, can you have major hurricanes in June, July, and November? Yes.
So why? Why is there that spread? And I think people need to understand that it starts June 1st, but, so first, why do we even have a season, if we can talk about that? And then why does it peak? It's kind of that lag there. What's so special about August through October?
Right. Well, what happens is, again, you have to have those different things lined up. So one of the things is the warm water. So the water is not really peaking out until August, September, October. You have some areas of warm water, but you don't have that real swath of sufficiently warm water. Also, you have to have these systems where the bulk of the season comes from. See, most of these early storms, June and July, form off of other disturbances, the end of cold fronts, things like that, some sort of large cloud cluster in the tropics that's concentrating that heat and that energy, whereas the waves, what generates the waves off of Africa, and we won't get into that there, that's a whole discussion itself, but what comes off, those don't really start in earnest until really towards mid-August.
Okay.
I mean, you have some early, but when we say August, frankly, if nothing happens till August 20th, we're not shocked. I mean, it's sometimes that's when the African season starts. And that's what generates the real strong winds. I did a paper back in 96, and it showed that the vast majority of major hurricanes started with these systems from easterly waves off of Africa in something we call, people have heard about the main development region.
Yeah, the MDR.
Which is 10 degrees to 20 degrees north between Africa and Central America. And that came out of our 96 paper, Goldenberg and Shapiro, and we saw that, number one, most of the major hurricanes started from these easterly waves and began development. We defined that as became a depression, became a tropical cyclone. Remember the circulation? It became in that main development region. So, by the way, one of the ways we predict the season, since you're talking about why the season operates like that, one of the ways we predict the season is we look at the overall climate factors, like what we think the sea surface temperature is going to be, the vertical shear, El Nino. When you have El Nino, this warming off of the in the East Pacific and Central Pacific, when you have that, you tend to have fewer hurricanes. That's a whole nother program. The different climate factors. We'll get into that maybe with Phil Klotzbach at some point. But when we look at those factors and we say, it's like looking at the lineup for a baseball game.
Yep.
So
keys to the game. Yeah.
Go ahead.
Yeah, keys to the game is what I call it. It's one of the many analogies. And Sports and Hurricanes will be the title of my first book, I think.
There you go. So we basically, it's like before the game starts, so we're making our forecast at the end of May.
Right.
And NOAA will put out the seasonal outlook at the end of May. Don't you wish we could postpone the season for a few months because of the COVID-19 outbreak? We only wish, right? But it's going to start on schedule, and we'll put out that outlook at the end of May. So right then, we think we know the lineup.
Right.
We're predicting the lineup. And so we say with that lineup, when everything comes into play, we're really looking at August, September, October. When everything comes into play, this is how many storms we think we might have. Now, when we update the forecast in August, beginning of August, we know the lineup. In fact, maybe they batted one inning.
Yeah.
So that at that point, we pretty much know what the climate factors are and how they're related to hurricane activity. So the activity, most of it hasn't happened yet, but we can say
good
with that
indicator.
kind of lineup, this is what we think is going to happen. And then the end of August comes and two of the players break their legs and the other ones get their head. So it messes up our whole forecast. But every once in a while we do get it right, and we make the outlook with that. But that's basically the season is like that. And if people ever look at a chart, it's good to post it, which shows the amount of activity from June 1st to November 30th, and you'll see June, July, and then as soon as you hit August, right up there to the peak in the middle of September, down again at the end of October, and then you peter out at the end.
If only
so it's very dramatic how much more activity. Go ahead.
If only we could flatten that curve.
There you go. We got to talk to the Hurricane Center about that. But let me mention something about that. That curve is climatology.
Right.
Climatology is an average of the activity for many years. You could have 1 year where August, bam, 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 and then September not so busy.
Right.
And October maybe bam, bam again.
Sure.
You can have 1 year where August through the beginning of September, a lot of activity, and then it flattens out at the end. It shifts around. But when you average all those together, the highest probability for busyness is right in the middle is September.
Sure.
And that's how it works. But let me mention that. I'm just going to mention. I'm jumping ahead since it's one of my favorite subjects is preparedness. And what people can think now is it's very, very unlikely they're going to have a tropical storm, even if they're in an area, tropical cyclone visit their area before June. It can happen, but it's very unlikely. And it's not too likely that'll happen before August, although you can get one, in July. And people can think now, what can I do? Start to make a list. What can I do to get my house, my family, more ready? And it's so important because we can learn and learn and learn. Dr. Neil Frank, who you and I both really appreciate and respect, who was the longest serving director of the National Hurricane Center, good friend of mine. He's in Houston now, and hopefully he'll be on your program at some point. And Neil used to say, he said, if we would make perfect forecasts, of course we don't have perfect forecasts.
Right.
He said, we still have to educate the public how to respond.
Right.
What do they do? What's going to happen?
What to do with that forecast.
We were mentioning the winds. People say, this is Cat 5. It's got more than 175 mile per hour winds. And then the storm hits their area and they don't get 175 mile per hour winds.
I know.
Well, that's because in a little area that's getting that. Plus, there are dust.
Yeah.
And Irma in my area in Miami, we did not have any sustained hurricane force winds from Irma. That was absolutely amazing. The number of trees that went down, the medium level of damage, very widespread, the power outages. But we had enormous gusts to over hurricane force.
Sure.
So the gusts are very important too. But can I just throw in this little thing on preparedness, Mark? I have
Please.
what's called the five P's of preparedness. If I say nothing else, I want to say this. And by the way, let me
Y'all
let me
pay
tie
attention
this
here.
into
5
COVID-19.
Ps.
Now, I'm not going to get into a discussion on details of COVID-19. That's not my area.
Well,
of
let me
expertise.
interrupt you and say one
Go ahead.
thing. As he is about to talk about this and bringing the COVID-19 into this talk, the parallels that we've all dealt with this pandemic are so similar to what we deal with when a hurricane's coming. It just seems like it's taking a lot longer. That we have computer models now for the COVID-19. We have experts that we hear from, just like we do when there's hurricanes. There's this, well, there's something out there, it's in China and now it's here, and that's kind of like, well, there's a tropical wave out there that might develop. The parallels of how hurricanes and this pandemic have developed are absolutely uncanny. And so I think it's very appropriate to bring in your insight, especially as a research scientist, further insight to how that parallel does work as my allergies start to kick in. So take it away.
And I got a tickle in my throat. But well, let me just
Pine
say this,
pollen.
I don't want to delve too deeply
Right.
into the actual COVID-19, but I've been talking to a lot of people. I've been looking, and as a researcher, I look at the raw
Sure.
data myself. And one thing you realize, the experts are not always right. The forecasts are not always right. The impact is not always exact.
Right, that same
and those are
parallel.
similar.
Right.
But what is so similar too is the reaction of people. I see people panicking, absolutely in dread and fear, and just almost curling up in a ball with this thing. And I see people on the other end of the spectrum, oh, it's all a hoax,
Right.
and we don't have to worry about it, it's all Chinese plot, and I'm just going to carry on my life as it is. But what do we want is people in the middle, just like with hurricanes. We don't want to fear that. That's hard. When you've been through a Cat 5 storm like I have, you've got a little bit of fear there.
Sure.
I'm going to use the word respect.
Right.
You respect their power and the impact, but you say there are things I can do.
Correct.
That's like with COVID-19. It's like, let's do the right thing. Let's respond. As if I could mention Dr. Oz, he had this one headline that says, in the middle of this dangerous situation, let's stay calm and not panic. That's what we want with hurricanes.
Exactly.
We want people to stay calm, not panic. And with hurricanes, we know that season is coming. Do I know whether your area is going to get hit?
Right.
No. And in fact, when we put out the NOAA seasonal outlook, it doesn't tell you anything about whether your area is going to get hit.
Right.
Everybody's got to still be ready. We know a busy year, you tend to have more of a chance of having storms in the Caribbean. A slower year, those are very rare. But in the U.S., in 1992 with Hurricane Andrew, that was a fairly slow year.
Right.
There wasn't much going on. We had one strong storm, it was Andrew, and half of Miami was
Sure.
devastated. So people have to be ready every year, and that's what we don't want people to panic. We want people to realize and say. That's why I say now people can start thinking, what do I have to do to be ready for the season? Let me not be the people who rush out
Right.
at the last minute when a storm's bearing down, we're under a warning, and I'm scrambling for plywood to throw on my windows and water. By the way, a little tip with water is people panic, even like with the current situation. The grocery store's out of water, what am I going to do? And I say, do you have a tap at home?
Right.
Do you have any containers?
Yeah.
What I do, I have a water filter at home, and I have a bunch of empty bottles. I have all these 2-liter seltzer bottles and gallon bottles, and I just keep them empty. And when it comes to a storm, I fill them all up.
Right.
I mean, that's why
It's
I don't
common
have to run to
sense.
the grocery store for stuff like
Right.
that. But we want the non-perishables. The difference with COVID-19, a big difference, and what we deal with hurricanes, even a medium one, even a strong tropical storm, you can be dealing with a long-term power outage.
Right.
So you have to have either generator supplied power or non-perishable food to
Right.
depend on. And that's a biggie. Thankfully, we're not dealing with that with this situation.
Right.
Let me go through the 5 P's of preparedness.
Yeah, let's get
And I
back
hope
to that.
people
Right.
Yeah, I hope people remember this and write this down. and came up with this years ago. And I think they first presented it there in Carolina. I think I was giving a talk at North Carolina State or the North Carolina Governors Conference somewhere, and this is where I first came up with these. So number one is protect.
Protect.
The key thing, most important of anything, is to protect life and property.
Makes sense.
In that order, right?
Right. Exactly.
You have to know. Yeah, we want to protect our life. We want to protect our property, and there's all sorts of things and mitigation things we talk about with that. But P number 2 is provisions.
Yeah, your
Why
stuff.
do we need that? We need to understand what provisions do we need.
Right.
Emergency provisions that maybe I'll be without power a week or two. In Miami, there were no grocery stores. Things were just wiped out.
Sure.
I mean, people came in and brought us supplies. If you didn't have a generator, didn't have electricity, always have special needs provisions. You have babies in the house.
Right.
You got to have an extra supply of diapers. You got to have medicine for people.
Yeah.
You're talking about, say, someone who's diabetic. Talking about you better have a 2-3 week supply
Right.
of insulin for them. They're talking about serious stuff, life-threatening stuff, because you might not be able to get to a hospital.
Right.
You might be able to get to a drugstore or a place. And you can't depend on people bringing the stuff to you. So you want to have those emergency supplies. And when you do these, by the way, it's good to have them in place which you can by June and have them stored properly, or at least before August. We hope you do it by then.
Right.
So provisions, all the different provisions, the water, the food, I have all sorts of shakes I can make and meal bars and stuff like that. But again, perishable, non-perishable items. So then we have, that's just my little alarm on my wristwatch.
Thought I was in here.
Then we have P number 3 is plans.
Okay.
You want to know what your plans are going to be. For instance, Mark, are you in an evacuation area?
Right, exactly. And no, I am not.
You are not.
I know that.
Now, say if someone lives in a mobile home,
Right.
okay, they need to evacuate that if it's going to be a strong tropical storm.
Right.
But an evacuation from a mobile home is much easier. You take everything you ever want to see again, because if it's strong like Andrew, they were just demolished.
Sure.
Take everything you want to see again, and go
Leave.
to
Yeah.
either a shelter or a friend's house.
Right.
I was in a mobile home for a while in Fort Lauderdale, and we knew which friend's house was 15 minutes away.
Yeah.
So I could wait till we absolutely knew the storm was coming and bearing down on us, and then we would hightail. So, but say you live on a barrier island, say you live in the Florida Keys, say you live on the Outer Banks.
Right.
They need a much longer lead time. You know what the lead time is for the Outer Banks, Mark?
Yeah, the clearance time up there in some cases can be more than 24 hours to 36 to 48, depending on the time of the season, and the Florida
And in
Keys.
Key West,
Right.
in Key West, it's 72 hours.
3 days, right.
In 3 days, because they have that one highway, they've got to get out of there. And but plans like,
Yeah, plan.
okay, if I evacuate, where am I going to evacuate
Right.
to? What am I going to do? Say I have a job that requires me to be there.
Yeah.
For instance, like with me, I might go out flying and we have a storm coming in where I want to make sure my house is prepared, that my family is protected. And there's all sorts of things like that. Maybe some people put their shutters up way early because they're not going to be there when the storm hits. So there's all sorts of factors. What do you want to do with your plans? And again, know, am I in a storm surge area when I have to evacuate? The fourth thing is predictions. Follow the predictions, and I say this very carefully. Follow the predictions.
Listen to
of
this, the
National
predictions.
Hurricane Center.
Right.
National Hurricane Center, short website, hurricanes.gov.
Right.
Hurricanes.gov. You hear all sorts of things on the media. Some of them get it right, some of them don't. Follow what the Hurricane Center. Learn their website. They have so many wonderful.
They really do. And let me jump on you. We're going to have an entire edition of Hurricane U solely dedicated to understanding the products from the National Hurricane Center and your local National Weather Service office. We're going to get into that as an entire episode down the road because it is right there at your fingertips. I use their products a lot when I do my video discussions, and I call it the largest crowd-funded weather site in the world. It's weather. Right. It's our National Weather Service, and we all pay for it with our taxes. Definitely need to utilize that. So we're going to get into that in detail.
That is great, Mark, and I urge everybody to make sure I know when that program
Oh,
is
yeah.
on air. They've got so much wealth, and every time they come up, you don't know the thought and the effort and research that
Right.
goes behind each new product. One of my favorite newer ones is earliest onset of tropical storm winds.
Right.
Why is that so important? Because you aren't going to be able to put up boards and shutters
Right.
once those winds really kick up. And most likely onset, they've got all these wonderful maps. They have the discussion section. They even have some PSA, some public service announcement videos. They have their first one, which is on understanding
Right.
code. And
Right.
people can simply go to bit.ly/NHC cone, all small letters, and they can see that, or they can go to the Hurricane Center site and find that. They've got so much wealth of information on that. I'm not saying listen to the news, but you got to balance it with the information coming
Absolutely.
from
The prediction.
And so you want to follow and understand those predictions.
Right.
And then the first time I gave this talk in Carolina, someone from the audience said, I got a fifth P, how about prayer? So I said, okay, that's a winner. So my fifth P is prayer. And I believe in prayer, and that's a good time to pray. I believe a lot of people were praying during Andrew and some of these stronger storms. So those are my 5 P's of preparedness.
Now, a good friend of mine has told me on the subject of hope and prayer that, and you have to make sure people understand this, that hope and prayer, mutually exclusive or not, alone are not planning tools. And that is very important, that they are part of, look, it's number 5, it's part of your package there. Hope, prayer, whatever you want to call it, by itself is not a planning tool. And I think a lot of people will dismiss it. You talk to them about a hurricane is coming, etc., and they will literally, I've heard them say, well, I just hope it doesn't come here. I pray it won't come here. And I fear that sometimes they will use that to ignore it for whatever reason, that I don't want to deal with it, so I'm going to hope it away. I'm going to pray it away. But you got to remember, you need to use that as part of the other 4 P's that Stan just talked about, that it's part of that toolkit. We're smart. We have to use the whole package. You can't just, hope is not a planning tool.
Listen, what you're saying is very important because it goes further. That hope can also be, another word is denial.
Right.
And frankly, when Andrew was coming our way, when you see my story at bit.ly/Goldenberg, Andrew's story, I think it is.
And I'm going to put the links to this in the description, folks. Do not worry. Absolutely.
When you see my story, I was having a baby the night before
Right.
Andrew, our 4th child. We were in the hospital, and I could not believe this Category 5 hurricane was coming our way. I was in denial. I didn't want to admit it. I mean, it just was so rough to even imagine that. And
I can't imagine.
We have a phrase, and it says, hope for the best. It's an old Russian proverb, prepare for the worst.
Yeah,
so
simple.
let's hope it doesn't come our way, but you got to prepare for the worst. I got to tell you about prayer, because there's people who just say, I run into it all the time, and I believe in prayer. I believe in the power of prayer. You say, well, we're just praying the storm away. Storm, you're not going to come away.
Right.
I say, well, you really better know that it's not, because this is life or death. And we had a friend in Hurricane Andrew who, her name was Ann Harris, I'll mention by name, wonderful friend, and I'd been in contact with her for a while, and she lived down in Naranja Lakes condominiums. And I said, Ann, are you evacuated? Because she was in an evacuation area. He says, no, God's going to take care of it. And I said, Ann, you better know this is life or death. After the storm, guess where the highest concentration of deaths were? Naranja Lakes condominiums.
That's right.
And after the storm, I sought her out, and I got a hold of her, and I said, Ann, are you okay? And I can feel the emotions when I really touch the Andrew story. Maybe we'll have a whole one talking about my Andrew story, but they can watch the video. And I get emotional. I just start talking about it. But anyway, I said, Ann, so tell me what happened. Did you evacuate? And she said, yes. I said, what finally convinced you to? I love what she said. She said, I found out it was an order, it was law, and I obeyed the law. And I got out of there.
There you go.
And boy, was she glad.
Common sense, right.
She did. So yes, she prays. And once you believe in the power of prayer, but there's times you've got to be, some storms are stopped and don't come our way, and some storms do. So you have to be ready for whatever. So hope for the best, prepare for the worst.
Exactly.
As much as we don't want to admit that it could come our way.
Well, we're going to wrap up here in the next couple of minutes, this first edition of Hurricane U. Again, the whole idea of bringing in an expert, somebody that knows the subject matter. And there's a lot, we could go on for hours, and we will when it's all said and done. This will be several hours of this once it's all accumulated over the next several weeks. But just kind of recapping what we've discussed, that we know we have a hurricane problem. We know that we have a season. We get the general idea of how hurricanes form. They are a product, generally speaking, of the warm ocean. Tropical cyclones are, and other factors in the atmosphere that give birth to hurricanes. We know we have to prepare for them. In the world of climate, we talked about this just a little bit. A lot of people seem to think that climate change is making hurricanes worse. And to that end, I had a question from another one of our supporters. Is this short-term drop in industrialization around the globe, do you see that having any impact on CO2 in the atmosphere that would infuse some kind of a change in the weather, or is it just too soon to know? I know I'm throwing a lot at you. These can be some very touchy subjects, but it's
That's a lot. Now, you said I got 20 more minutes here. Let me wrap this up in about 2. First of all, by the way, I want to give one of the best analogies on this latent heat of condensation and evaporation. People want to know how strong that is.
Love
How
analogies.
many of you have been in a sauna?
Okay.
And the proper way to do a sauna is you take water, bucket of water, and you throw it on the rocks. Now, that will create water vapor. It'll travel across the room invisibly. But when it hits your body, whoa, you really feel it. Why? Because it's condensing on your body, releasing all that latent heat.
See, there's science for you, folks. That's great. Condensation is a warming process. Evaporation is a cooling process. See, you just learned some basic meteorology today.
Exactly. If you want to keep a cup of coffee or something hot the longest, put a top on it so that it's not able to evaporate and lose all that tremendous energy through that vapor. But let's go back to climate. First of all, let me say something about climate change. The climate is always changing. People ask me if I believe in climate change. Climate's always changing.
Right.
Okay. But when they talk about man-made or anthropogenic climate change due to CO2, that's a huge topic that we can't touch on much here.
Right.
I encourage people to look at something called climaterealityforum.com. That's not a NOAA conference. And I did speak there. I spoke on hurricanes and climate. And people can go there and at the bottom of the page see my talk on hurricanes. Because many of us feel, although there's some that is stated otherwise, science is give and take and back and forth.
It is, right.
Let's see, should I say this real soft, Mark, so nobody really hears it? Sometimes at our lab, we have almost knockdown dragouts.
Sure.
I mean, verbally, arguments and stuff, and that's how good science is born. I mean, they say, well, no, you're wrong with this and you're right with this, and you've been there. You've been the subject of it sometimes when you present your stuff at our lab, and but that's the same thing with that. But there's the experts I really respect in this area. We feel that if there's any difference from anthropogenic climate change, changes in climate have a tremendous impact on hurricane activity. But from anthropogenic climate change, I see personally, and many others that I know, including Cloudspot, Chris Clancy, others you might have, see very little, if any, impact on hurricane activity. So the fact of not having CO2 for all this time, I think is going to have very little impact on the weather right now, and certainly very little impact on the hurricane season as it comes up. So people have to realize we are seeing hurricanes. I'll just mention one other quick thing with that. One of the biggest climate fluctuations, I like saying climate fluctuations, because that implies it can go up and down in cycles, is multi-decadal scale. And that means we had a period where there were certain factors, again, time for another talk, but where the Atlantic was particularly more conducive for stronger hurricanes for several decades through about 1970.
Right.
And from 71 to 94, we didn't have a single year with more than 3 major hurricanes.
Right.
It was a very suppressed time. Now, during that time, we still had Hurricane Andrew, Hurricane Hugo, Hurricane Allen. Not that there weren't any strong ones or any Cat 5s, just not as many. And then you hit 1995, and it shifted back up again, and we're now in this high activity era. So those changes are huge and much more than anybody would expect from anything man-made. These are natural cycles
Right.
that we've seen go on actually for hundreds of years. So I hope that's a good wrap-up. The issue is hope for the best, prepare for the worst, whether we like it or not. Hurricane season is coming, and we want to learn about it through things like your program, learn more about it, and learn how to prepare, and then take those actions. I should end with this, Mark. There's a wonderful scripture. Now, I'm not preaching Bible here. It just fits so well. It's Matthew chapter 7, verse 24 through 27. It's the end of the Sermon on the Mount. So Jesus, or we say in Hebrew Yeshua, is speaking, and he says, those who hear these sayings of mine and do them, they're like a man that built his house on a rock, and the winds came, and the floods came, and the rain came and beat on that house, and it stood. I'm not quoting exactly. But then it says, they who hear these sayings of mine and don't do them are like a foolish man that built his house on a sand. The other was a wise man. And the winds, rain, floods came, beat on the house, and it fell.
Right.
And what I say to people is, hear what we're saying, but then do something about it.
Absolutely.
And get ready for the season. Because rain, wind, flood, that's a hurricane to me. So, so we can do something, be more ready, and hopefully you're going to have lots of interesting stuff in your programs to come. Thank you so much for the privilege of being the first interview you do on this program.
And that's just what we're talking about here, folks, is that we have this opportunity ahead of hurricane season each year to learn more, to expand our knowledge, and to not be fearful of what we're up against. You know, right now we are in an incredible time in world history with the pandemic that we're dealing with, and hurricane season is coming no matter what. But instead of thinking of it as piling on, that nature is somehow against us, I like to look at it, you know, we know hurricanes. We've been there before. Let's act like we've been there before. You know, my sports analogies, I use them a lot in my hurricane outlook and discussions. Does it ever aggravate you when you see a team win and they act like that it's the greatest thing ever when it might just be some game in the regular season, and you go, man, act like you've been here before. You know, show some respect for the game, whatever it is, baseball, basketball, football. And it does. It aggravates you as the losing side. Usually you see them overreacting and you say, oh, come on, act like you've been here before. I think that is the advantage that we're going to have going into this hurricane season. We have a lot on our minds, a tremendous amount of anxiety and stress with the COVID-19 issue. But the gift here is we know hurricanes. We're not perfect at it, but we have a grand knowledge base. We have the internet at our fingertips. We have people like me, people like the folks behind the NOAA sites, weather.gov, hurricanes.gov, and then other folks out there that collectively give us the tools that we need to not be afraid. I want you to not be afraid. And, oh, hurricane season, I don't want to hear about it. Let's flip that around and say, you know what? As unpleasant as they can be, we got this. We got hurricane season. If we can handle this pandemic, and I know that's putting it, you know, I'm optimistic there, but we can handle hurricanes. That's the way I look at it. So we're not going to pile on. This is going to continue to hopefully enlighten you and motivate you to, you know what, Mark's right. We got this. We've been through lots of hurricane seasons as a country, and we will get through this one. And Stan, I appreciate you joining. Any final thoughts before I press the button up there and turn it off?
Wrapping from what you've said is that as far as we've got this, we understand how devastating they can be, but how we can get ready to do whatever we can to protect life and property. Because you have an area like from Hurricane Michael that experienced tremendous devastation, but very little loss of life because people responded the right way. That's our key thing. You can rebuild a building. We can't pick you up once you're dead. I hate to be so sober with that, but that's what it is. So we want people to be protected with that. And I'll end on a more upbeat note, is people often ask, you might have some people out there watching, younger people say, hey, or older people, I always want to be a meteorologist. By the way, you don't have to be a meteorologist to be involved in this field of hurricanes and weather. There's
Right.
lots of
I'm not.
positions for computer programmers and secretarial and electronic engineers. We have all sorts of. But as far as being a meteorologist, it
Geography.
requires a lot of math, a lot of math.
Yes.
Calculus of every different kind, physics, some chemistry, and then some wild meteorology courses. So it's a rough major, but some people are suited for it. I love it, and I'm so grateful that, honestly, my mother suggested that I try weather, and I'm glad she did. So thank you so much, Mark. You have a great day, and I hope we have a boring hurricane season, but we'll find out when it happens.
Right, and so let me just let you know what's coming up next. Next Wednesday, I'll do this again live from my daughter's bedroom in Wilmington, North Carolina.
Love it.
What a world. We're going to talk about specifically, we're going to start to focus now on more specific topics. And so next week, we're going to drill down into the world of hurricane tracking. How do we track them? And we'll go from there. All right, so that'll be next Wednesday, 4 p.m. Eastern Time. I do not know who my guest will be, my expert, my phone a friend, if you will, but I'm working on that. People are still busy. Jesse Bass, I know he's watching right now, and Stan, you know Jesse Bass.
Hi, Jesse. Oh, yeah. Hi, Jesse.
He knows this phrase well. Jesse knows the inside story to what I'm about to say. We may not look busy, but we're busy. So some of these people are very busy, and it's not like they're all sitting at home. Boy, I hope Mark calls me, because I would just love to be on his Hurricane U program, but I'm working on it. And we will talk about hurricane tracking on the next episode of Hurricane U. A reminder, I will put links to all the different links that Stan talked about and that I talked about in the description of this video. I will edit it down to chop off the front and the end so it's nice and neat, and I'll put the links in the description of this video on YouTube. We are supported by Patreon. You know what Patreon now is, I'm sure. It's a crowdfunding site, and it's like public radio. You know, a few people support something for the greater good, and this is made possible from our supporters on Patreon, and you can learn more about that, patreon.com/HurricaneTrack. Stan, thank you so much for joining me on this first episode. It worked. I would say A+, so thank you very much.
My privilege, and I hope we have you do a talk soon for AOML.
Looking forward to it. Hey, everybody, thanks for watching. I'll see you next week on Hurricane U. All right, turn off the button.